Ladies and gentlemen, let's get this review started. Number one, they want you to find f plus g of x. This is function notation saying that they want you to add the f function with the g function, and they give you both f of x and g of x. So let's add these together. Again, they want us to add the f function, which is 3x plus 1, plus the g function, which is x minus 5. Now normally we would set it up with parentheses. 3x plus 1 is the f function, and they want us to add it with the x minus 5. However, in reality, you don't really need these parentheses. Why is that? Because there's a plus sign. Now if it were a minus sign, for sure you would need parentheses. That way you could distribute the minus sign to both. But right here, the plus sign, if you distribute it to both, it doesn't change any values. So it's kind of like if you could just, simply erase the parentheses or ignore the parentheses and just start combining like terms. So what could we combine? We could combine the 3x with the 1x. That'll give us a 4x. And we could combine the positive 1 with the minus 5. That would be a negative 4. So your final answer is 4x minus 4. And when you're typing this in, it says, please type in answers with no spaces between your terms. In other words, don't do 4x space minus space 4. Just type it all in together. If it happens to be like, if the answer were negative 5x minus 7, you would just type in the minus sign, the 5, the x, the minus, the 7, no spaces between your terms. Moving on to number 2. Given those two, f of x and g of x, and I believe we're working with the same f of x and g of x functions throughout all of these, they want us to now find f minus g of x, which is really subtracting. So right here it is more important to recognize the parentheses, right? So let's do the f of x function here minus the g of x function here. So the f of x is 3x plus 1. The g of x is x minus 5. So as you can see, it's very important that we distribute this minus sign right there and right there, giving us a minus x and a positive 5. Now the 3x plus 1, since there's nothing to distribute out here in front, nothing there, we could just ignore the parentheses and just have the 3x plus 1 come straight down. So now we have 4 items here, and we could combine like terms. So let's combine the 3x with the minus x. That'll give us a 2x. Combine the positive 1 with the positive 5. That'll give us a positive 6. That is why our answer is 2x plus 6. Again, type it in with no spaces between your terms, right? 2x plus 6, no spaces. Moving on. Question 3, again, we're still using the same two functions, f of x and g of x, and they want us this time to multiply them, right? F times g of x. So they want us to take the f of x function and multiply it by the g of x function. So here we go. F of x right there, g of x right there. F of x is 3x plus 1, so 3x plus 1 times my g of x function, which is x minus 5, x minus 5. Let's distribute. Let's distribute the 3x first. 3x times x is 3x squared. 3x times negative 5 is negative 15x. Now let's distribute the positive 1 right here. Positive 1 times x, that's positive 1x. Positive 1 times negative 5, that is negative 5. Now after distributing, we should always combine like terms, those middle terms, the negative 15x and the positive 1x, that's a negative 14x. So our final answer is, let me write it up here, 3x squared minus 14x minus 5. That's our final answer. Now, because these are mostly open response questions, it gets a little more challenging because, first of all, you don't have the math program to be able to type in the exponents and stuff. So here, I give you an example on how to type in your answer. It says type in answer with no spaces between your terms. Use this caret button, the shift 6 button, or at least for most computers, I don't know. Shift 6 will give you that caret to be able to write your exponent. So the example is, if your answer is 9x squared minus 3x plus 5, you would type it in as 9x caret 2. That would be saying 9x squared, and then minus 3x plus 5, right? So I give you an example. I give you an example of how to type it in. So we need to type in 3x squared minus 14x minus 5. Here it is, 3x caret 2 minus 14x minus 5. No spaces between your terms. That is how we are going to type in the answer to get it correct on the midterm. Let's move on to question 4. Question 4, we have the same two functions, f of x and g of x. 3x plus 1 and x minus 5 are the two functions. And they are telling us f over g of x. That's saying f divided by g of x. So you're simply, like, on the open response part, because I will give you a piece of paper where you show your work. Now, on this multiple choice one, I do ask, what value can x not be? What value can x not be on this, all right? So let's first write it out on your paper that you're going to take a photo of to turn in accompanying this quizzes. You're going to show this work, the f of x being over the g of x, okay? So what we're going to do is actually show that. We're going to put in the 3x plus 1, that's the f of x, over the g of x, which is x minus 5. This is your answer, right? This is your answer. However, on this question on quizzes, they're not asking for the answer. They're asking for what can x not be. When you do this, when you get this, what could x not be? And you should look at the denominator and make sure that that denominator cannot end up being 0. So x minus 5 cannot end up being 0. Let's think about that. X minus 5 cannot end up being 0. So just solve that equation. So you add 5, that's saying x cannot be 5. And that makes total sense, because if x were 5, 5 take away 5 would be 0, and anything divided by 0 is undefined. And of course we don't want that. So yes, the answer to this multiple choice question is x cannot be 5. So here is your answer. X cannot be 5. Moving on. Question 5. Is there a difference between f plus g of x and g of x plus f of x? Is there a difference plus f plus g of x and g of x plus f of x? So this is the notation, f of x plus g of x. What I'm trying to say is, let me write this out. F plus g of x, that's the notation for f of x plus g of x, okay? So they're asking, is there a difference ultimately between this guy and this guy? So what is the difference between this and this? The only difference is that there was an order switch, right? The f of x got over here and the g of x got over there. And we know that if we actually had functions, like on the previous ones, I'm not sure if it was exactly this, but like let's say f of x was 3x plus 1 and the other one was x minus 5, right? Is there a difference if you have this one first or that one second at the end of it all when you get your answer? And the answer is no, right? There is no difference. I mean, think about it, right? If you have, let's even make it more simple, 3 plus 2. If you change it to 2 plus 3, is there a difference? No, it's still going to equal 5. All right, so this is in your own words and complete sentences. And of course, I'm going to read these to see if you get credit. And as long as you don't give me something that's like, that doesn't make sense, right? As long as what you're saying makes sense, then you're good, right? So f plus g of x compared to g plus f of x, is there a difference between them? You could put just the order in which you add, but at the end of it all, there is no difference, right? So at the end of it all, there is no difference because you're just switching the order of addition, and that doesn't change the final answer. Let's move on. Question 6. All right, they give you f of x and g of x. They want you to find, and here's a notation, f of g of x. Once again, I hope we remember that you, like on all parentheses, you start with the inside first. The g of x is what you're going to be plugging into the bigger f of x function. Okay, let me repeat that. The g of x is what you're going to be plugging into the bigger f of x function. Okay, so let's go to the g of x, and I'm using blue so you guys could see. The g of x function is blue, into the bigger f of x function, which is 5. So I would write the bigger f of x function first. The 5x, I would write like this, 5x. Big giant 5 and big giant parentheses instead of x. Then I would plug in the g of x function into it. The x minus 2 goes right in there. And now you could actually do some math. Distribute 5 times x, 5 times -2, 5x minus 10 is your final answer. That's what you would type in with no spaces between your terms. And that's what you see right here as the answer, 5x minus 10. Let's move on. Question 7, f of x and g of x, 5x and x minus 2, they want you to do the other way around. Instead of f of g of x, they want you to do g of f of x. So this time they want you to plug in the f of x into the bigger g of x function, okay? So the g of x function is going to be the bigger one. The f of x function is going to be the small one that's getting plugged into the bigger g of x function. So let's start by writing the bigger, the outside g of x. Let's write that first with big parentheses, right? We're going to write it as parenthesis minus 2, right? Instead of x minus 2, we're going to put parenthesis minus 2. And what are we plugging in right into here? We're plugging in the f of x function, which is 5x. So we plug in a 5x right there. Now, is there anything to do right here? No, there is no distributive property. There is no multiplication. There's not even multiplication over here. This is saying this, which is 5x minus 2. That's not times -2. It says, right here it says x minus 2. That's what this says, 5x minus 2. What about the parentheses? Erase them. You don't need the parentheses. And there's your final answer, 5x minus 2. And again, you type in that answer with no spaces between your terms. Now on this one, I do want to warn you, do not leave it in parentheses, okay? Do not leave it in parentheses, all right? You have to erase those parentheses, type it in 5x minus 2 with no spaces between your terms. Question 8, f of x is 5x, g of x is x minus 2. Is the following statement true? The statement is g of f of x equal to f of g of x? Yes or no? Explain. Well, technically, if you've been working on a piece of paper, you should see, because we did both g of f of x and f of g of x, you should see that they are not the same answer, okay? So let me just quickly showing you, f of x is the red, the g of x is the bigger blue. So I'm plugging in the red f of x, the 5x, into the bigger blue parenthesis minus 2. Okay, and we're dropping down the equal sign. We already did all this work before. You should be able to look at your paper and see whether they're equal or not. Now on the other one, it says f of g of x. So I am going to write the bigger f of x function, and then inside that bigger f of x function, I'm going to plug in the g of x function, x minus 2. And as you could see, when you simplify this, the left side is just 5x minus 2. Bring down the equal sign, distribute the 5, that'll be a 5x minus 10. And of course, these guys are not equal, right? These are not equal. So is the following statement true? You would say no, they are not true, they are not equal. And you could even show this work stating that they're not equal because one is 5x minus 2, the other one is 5x minus 10. And that's about it. Let's move on. Let's talk about inverses now. So question 9, there's your f of x function. They want you to find the inverse. Now, I hope we remember that, first of all, this f of x is really y. Okay, so f of x is really y. You might want to jot that down. Y equals something squared plus 5. What is that something? It's x minus 2. Okay, so how do we actually find the inverse? How do we find the inverse? Well, you should remember step 1, after changing the f of x to a y, step 1 is to switch x and y, just magically switch them, and then solve for y, okay? Again, switch x and y, then solve for y. So we have x equals y minus 2 squared plus 5. Y minus 2 squared. We need to get that y by itself, right? Because step 1, switch x and y, and then you solve for y. So we need to isolate y. We need to get y by itself. Let's subtract 5. Subtract 5. We will have x minus 5 equals, parenthesis, y minus 2 to the second power. Now, if you don't want the power of 2, you get rid of the power of 2 by doing the opposite, which is the square root. And what you do to one side, you do to the other side, the entire side, that is. So yes, the square root and the square eliminate themselves. You will have a y minus 2 left over equaling the square root of x minus 5. Now that minus 5 is inside the square root, as you could see. We now need to get rid of the minus 2 at the very end where the y is at. So I am going to add 2 here, add 2 over here. Now you can't really add a radical with a nice natural number 2, so I'm just going to rewrite it. The square root of x minus 5 with a plus 2 on the outside equaling y. Better word, or better written, y equals square root of x minus 5 with a plus 2 on the outside. Okay, so our multiple choice answers have the inverse function notation. The inverse function is the square root of x minus 5 plus 2, and that is the correct multiple choice answer. Now keep in mind, guys, that even though some of these are multiple choice, you will not get credit for it if you do not have this work right here shown on the picture that you submit accompanying your midterm. So please make sure you show all of this work. Question number 10. This is a written response, right? What is the first step to any inverse problem after changing the f of x to a y? Well, I mean, think about it. What do we do after changing the f of x to a y? What's the first step? Well, it's this. It's switching x and y. So that's what everybody should write down, or that's what everybody should know. Switch x and y, and then solve for y. I mean, you could put switch x and y because that's the first step, but this is the entire thing. Switch x and y, then solve for y. Either one of those responses will give you full credit. Let's move on to number 11. Number 11 is a good one. And since you don't have the ability to type in square root symbols, I do want you to write out your answer. Okay, so for example, if your answer is this, 3 square root of 4 minus 2 square root of 3, that's what I want you to write. 3 square root of 4, 3 square root of 4, minus 2 square root of 3, 2 square root of 3. Okay. Now, of course, you are going to have to actually show your work on that picture that accompanies the midterm, and you should have everything perfectly written right there. But on this response that you're typing in onto quizzes, I do want you to write it out with words, except for the actual numbers, right? 3 square root of the number 4 minus the number 2 square root of the number 3. Okay, anyway, let's actually do this guy. And let me rewrite it over here so we could have more space to do this. And let's zoom in a bit. So we're going to begin by simplifying these square roots, right? And how do we simplify square roots? You want a perfect square number right there. You want the number 4, you want the number 9, the number 36, the number 25, but you don't want 75 because 75 is not a perfect square number. So let's rewrite it with multiplication to get a perfect square number. So 75, you could rewrite it as 25 times 3. And then you could split the root, and that'll give you 5 square root of 3. But don't forget about this times 2 that's out here in the front. So bring that down, times 2. And since you have a nice 2 times the nice number 5, that'll give you a total of 10. And we are talking about square root of 3 right after that 10. So you have 10 square roots of 3. Okay. Now let's do the next one. The next one is 12. We're going to rewrite that as 4 times 3. Not 6 times 2, but 4 times 3. Split the root. You'll have 2 square root of 3. And that's all there is to do. Oh no, let's not forget about the times 4 that's out in the front. So put times 4 right here. That would give you a final positive. 4 times 2 is 8 square root of 3. Okay. And last but not least, let's do the same over here for 27. That's really a 9 times 3. Split the root. That'll be 3 square root of 3. Don't forget about the multiplication of, might as well call it a negative 4 times negative 4. That'll give you a negative 12 with the square root of 3. Now check it out, guys. Down here we have all the same exact type of radical. You have 10 of these square roots of 3's plus 8 more of these square roots of 3's. Take away 12 of those exact square roots of 3's. They're like terms. You could actually combine those. So that really becomes 10 plus 8 is 18. 18 take away 12, which is 6. So your final answer is 6 of those square roots of 3's. So when you type it in, you'll type it in as 6 square root of 3. 6 square root of 3. Explain why you cannot simplify the above expression, the square root of 13. That's pretty simple. You cannot simplify the square root of 13 because 13 is not a perfect square number, and you cannot rewrite it with multiplication to get a perfect square number. That's it. That's your answer right there. That's your explanation. Of course, you might use different words, but at the end of it all is you want a perfect square number. So if it's not a perfect square number, you want to rewrite it with multiplication to get a perfect square number. And 13, you cannot break that down to get a perfect square number. All right. Again, don't worry, I won't be too picky when I'm grading these open response questions, as long as it makes some type of sense. As long as okay, I get it, I understand what they're saying, and as long as it makes sense, you'll get full credit. But as long as it's not something crazy, like if you just say, oh, you can't simplify the square root of 13 because 13 is an odd number. What? That doesn't make sense, right? Because you could simplify the square root of 27, which is an odd number. All right, I'm talking too much. Let's move on. Question 13. First of all, I made a mistake right here. This should be a minus. So let me do this. Instead of 3v plus 2, it should be a minus 2. So let me change that plus to a minus. I did make the change already on Quiz's website, but I'm not sure if it automatically updated it to you. But just be aware this should be a minus, not a plus, on the practice midterm. So let's actually work through this. Let's solve this thing by getting rid of the minus 28 first. Again, you want to solve for v. That means you want to get rid of everything except for v. And of course, you're going to begin with this minus 28 by adding 28. What you do to one side, do to the other side. You will end up with your new equation, parenthesis 3v minus 2 to the 1/5 power equaling negative 2. Now, to get rid of the power of 1/5, you're going to have to use a power, the whole thing, power of 5. And when you do to one side, do to the other side, power of 5. So, of course, power to a power multiply, 5 times 1/5 eliminates. So you will end up with just the 3v minus 2 right here, equaling, and if you do negative 2 in parentheses to the 5th power on the outside of the parentheses on your calculator, that will give you negative 32. All right, negative 2 times negative 2, that'd be a positive 4, times a negative 2 is negative 8, times negative 2 is positive 16, times a negative 2 is negative 32. So what you do to one side, I'm sorry, I'm getting ahead of myself here. You want to get rid of the minus 2 next, so you will add 2 to both sides, and that will give you 3v equaling negative 30. Final step would be to get rid of the 3, the multiplication of 3, by dividing by 3, thus giving you your final answer, v equals negative 10. v equals negative 10. And you're going to type in your answer with no spaces between your terms, v equals negative 10, no spaces. Moving on. The fractional exponent in problem number 13 is the same as what radical. Please refer to your open-ended PDF on this midterm. Again, with this Quiz's midterm, you're going to have the paper that you need to turn in that shows your work. And if you look at the previous question, 13, you should see the power of 1/5, and you should know that that's really a 5th root. So on your multiple choice answers, square root, 4th root, cube root, none of these would be the correct answer. Okay, so none of these, because that would be a 5th root, right? The power of 1/5 is the 5th root. Okay, and better said like that, 5th root, or better written. Anyway, let's move on. Question 15. We have a division problem on question 15, and first thing to do is to rearrange this back into standard form, and then you have to decide whether you want to do long division or if you want to use synthetic division. It's great to use synthetic because there's no coefficient in front of your x, which simply means that when you do synthetic division, you'll be able to plug in the nice, beautiful number 2, right? Think opposite of what you see here. Nice, beautiful number 2, and then you write your coefficients of your standard form polynomial. So this is not in standard form. So let me rewrite it first, right here, right above. It's going to be 3x to the 3rd, and then you go to your power of 2 minus x squared, because it's a minus x squared. And then there is no x. So technically I have a plus 0 x. There is no x. And then at the very end, plus 22. So I need to take the coefficients of all of these guys, all right? So I'm going to write down the first leading coefficient, 3, and then minus 1, and then 0, and then 22. So that's how you set up your synthetic division. And as you go down, you combine. 3 plus nothing is 3. As you go up, you multiply. 2 times 3 is 6. As you go down, you combine. Negative 1 plus 6 is 5. As you go up, you multiply. 2 times 5 is 10. As you go down, you combine. 0 plus 10 is 10. As you go up, you multiply. 2 times 10 is 20. As you go down, you combine. Now, I'm going to put a line right here because this is going to be our remainder. And our remainder is 42. 22 plus 20 is 42. So what is our answer? Let's begin with this. If you originally started with a third degree polynomial divided by a linear, which is power of 1, x to the third divided by x, that'll become an x squared. So our answer is going to begin with an x squared. Again, if this highest exponent, or let me go up to the one in standard form, this would have been a 5, x to the fifth divided by x, then your first one would be x to the fourth. If this were x to the seventh divided by x, and this would be x to the sixth, right? So it's x to the third divided by x, going to be x squared. So I really have 3x squared plus 5x plus the constant 10 plus the remainder 42 over the original x minus 2, over the original x minus 2. Ladies and gentlemen, here's our answer. I hope we understand it. 3x squared plus 5x plus 10 plus the fraction 42 over x minus 2. And, well, apparently the answer is none of these are correct. Now, I'm not sure. For some reason, I think I actually put this one as this answer, which would be wrong. I don't know. I'm going to go back and change that. Hopefully you guys don't have a problem with this. But yeah, this should have been a 42, so the answer will be none of these are correct. I apologize for any mistakes I've done on this practice midterm. Question 16, right here they want us to divide the quadratic trinomial by this linear binomial, and because there's a leading coefficient of 3, it is wise to use long division. So let's set it up. This goes inside of the division box, this goes outside of the division box. And we're going to begin with our first terms. 3x times what will get us a 6x squared? 3x times 2x will get us that 6x squared. Now keep in mind this is a binomial, so we're going to have to multiply the 3x times 2x. And where am I going to write that 2x? Not right here because that's where the x squares belong, but 2x would be above this other x. We want to stay organized. So again, we're saying 2x right on top of the other x term. 3x times 2x will give us that exact 6x squared, 6x squared. And of course, when we distribute, that's that one, but 2x times 1 is 2x. So we're going to write plus 2x. And as you can see, it's all organized. X's on top of x's on top of x's, x squares on top of x squares. Once you multiply, you now need to subtract. So you put the subtraction bar. I would put it in parentheses and put the minus on the outside. That way you'll remember that you need to distribute to both of those. So what you really have is 6x take away 6x squared take away 6x squared, which cancels out. You really have a negative x with a negative 2x. That will give you a negative 3x. And we're going to bring down this minus 7. And now what do you do to the 3x? 3x times what will give you that exact value, negative 3x? That will be a negative 1. Negative 1, okay? So let's distribute negative 1 times the 3x. That'll give you a negative 3x. And then negative 1 times 1, that'll give you a negative 1. And of course, we will be subtracting. Put it in parentheses, put a minus on the outside. That way you'll remember to change those signs. So this will be a negative 3x with a positive 3x, which eliminates. You have a negative 7 with a positive 1, which will give you a negative 6. So your final answer is 2x minus 1 minus 6 over the original divisor 3x plus 1. So again, you're going to have minus 6 over the original divisor 3x plus 1. Let's look for that answer down here, which is right there, 2x minus 1 minus 6 over 3x plus 1. Question 17, select all true statements. Where are they? There they are. Okay, so this says the degree must be odd. Well, absolutely, because one end behavior is going up here into quadrant 2, one end behavior is down here into quadrant 4. Remember, if they were even, if the degree was even, they would both be up here or they would both be down here, end behavior. So the degree must be odd. That's absolutely correct. Fill that in. That's for sure, yes. It has 5 real zeros. What are real zeros? Real zeros are real answers. Okay, remember this, guys. Real zeros, answers, solutions, roots, x-intercepts all mean the same thing, okay? So does this really have 5 x-intercepts? It crosses once, twice, 3 times. So that is false. It only has 3 real zeros, okay? So do not include that one. What about this next statement? It says, as f of x. Now this is a little confusing because normally we talk about x first and then f of x. This time we're talking about f of x first and then talking about x. So it's saying as f of x, which is really y, as y goes to positive infinity. All right, well here's y, and they even have it as a f of x, so that makes total sense. As y goes to positive infinity, as you look at this graph up, going up, where are your x values going, right? Are they going to the left or to the right? As you go up, notice this is going up, and where is it going? It's going to the left, okay? So that means that that should be x approaching negative infinity, all right? Now, if this confuses you thinking about y first before x, just go ahead on your piece of paper, switch them, put as x approaches positive infinity, comma, f of x approaches positive infinity. Let's see if that's true. That's a little easier to see. As x approaches positive infinity, as you go to the right, the whole y values are going up. No, the y values are going down. So that is false. Okay, that is false. So do not include that one. Once again, to make it a little more clear, just switch the order, put the x first like that. As x approaches positive infinity, the y values go up. No, that's false. As you go to the right, the y values go down. So that should have been a negative infinity right there. So again, that is not a correct option. What else? The leading coefficient must be positive. Well, think about it, guys. The most basic odd degree function is y equals x to the third. And that, what does that look like? It has end behavior down here and up there. That's your snake-like curve. That's an odd degree function. And if you're totally lost, you could be like, okay, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So that's how we get this graph like that. And if you go -1 is right there, -2, -8 is right here. If you plug in the -2, you'll get -8. So you will get those coordinates. Or how about this? You could use Desmos to help you out think this through, right? Type in y equals x to the third, you will get this snake-like curve. The a value is positive. That's why the end behavior is down here and up there. Do we have an end behavior down here and up there? No, that must mean that the leading coefficient is negative. If on Desmos you type in a negative in front of your x cubed, what will happen is it'll flip like that. Whoops, that is disgusting. Let me see. It'll flip like that. So it will have end behavior up here and down there. So it says a leading coefficient must be positive. That's false because it would have the end behavior down here and up here if it were positive. It would have it down here and up there if it were positive, but it's not. So don't pick that one. And last but not least, as x approaches positive infinity, f of x approaches negative infinity. As you go to the right, does it go down? Yes, so that one is correct. So on this particular one, there's only 2 that are correct. The other 3 are false. That doesn't mean that on the midterm you're going to have 2 correct and 3 false. I mean, they could be all correct. They could be all false. I don't know. I hope you understand this. Let's move on to number 18. Select all true statements about the above graph. Here we go. The leading coefficient must be negative. That's absolutely true. So we're going to circle that one. Yes, because if it were positive, you'd have both end behaviors up here, right? But they're both down here. So we know that it's an even degree function. We know that the leading coefficient's negative. It says the relative minimum. So we need to remember what relative actually means. Relative means that it's not the absolute minimum. And if we think about what is the absolute minimum, there is no absolute minimum because it goes down forever. It's technically negative infinity. So is there a relative minimum anywhere here? Let's see, it's going up. That's relative maximum. Then it goes down. Here's the relative minimum. Then it goes up. And this is the highest point. This is not a relative max. This is the absolute max. All right. And the absolute max value is at the location, let's say 1.5 and 5 point something, right? So the relative minimum is at 0.2. 0.2? Hey, that's correct. That's the relative minimum, right? So that is correct. It's another one that's right. It has 1 real zeros. Well, first of all, that doesn't even make sense. It should say 1 real 0, but I put zeros. My bad. So it has 2 real zeros, 2 real answers, 2 real x-intercepts. So don't pick that one. Moving over here, the degree must be an even number and at least 6. Well, we know it's even. The question is it at least 6? I hope we remember that the number of direction changes will tell you the least degree possible. So up, that's 1, 2, 3, 4. That's not 6, that's 4. So this is at least a 4th degree function. It could be 6, but it has to be at least 4, right? Could be 4, could be 6, could be 8, could be 12, could be 122. But the bottom line is the directions. Look, it goes up, that's 1, goes down, that's 2, goes up, that's 3, goes down, that's 4. That's at least a 4th degree function, not a 6th degree function. I mean, it could be, but it must be at least a 4th degree function. The absolute maximum is about 1.5 and 5.2. Let's see. Is that absolute maximum 1.5 and 5.2? 1.5, 1, 2, 3, 4, 5.2. Yeah, that looks about right. So let's, and it doesn't say exactly, it says is about, so that makes total sense. That's another true statement. Moving on to the last question, ladies and gentlemen, select all true statements, and of course you can't see it. Let me fix that. It says the leading coefficient must be negative. No, we already said that if you were to type in y equals x to the 3rd on Desmos, you'd end up with end behavior down here and up there, right? And that is because the a value is positive 1. So it does have the end behavior down there and up there. That means that the a value, the leading coefficient, must be positive. So that's definitely not right. Leading coefficient must be negative. No, that must be positive. Number 2, there are 2 relative maximum values. Let's see, how many maximum values are there? Well, there is no absolute maximum because this goes up forever. But we have 1 maximum. Let me actually put it right there. That's a maximum. That's a maximum. Is there any other ones? Yeah, think about it. Look, it's going up, it's going up. Hey, it reaches a max height, then it comes down. And then it goes up again, and then, hey, it reaches a max height right there. So that's another relative maximum. And then it goes down, minimum, up, maximum, down, minimum, up. Never reaches a absolute maximum because it is positive infinity. So how many relative maximums do we have here? It says, right here it says there are 2 relative max values. Nope, there's 3, 1, 2, 3. So that's incorrect as well. What else? The degree of this function must be at least 7. Again, the least degree is based on the number of directions that it changes to. So look, we have 1, 2, 3, 4, 5, 6, 7. That is absolutely correct. At least 7. So this guy is a winner. Moving on, there are 3 relative minimum values. Well, let's go through and see the minimum values. I'm going to do the minimums in blue. Up here, and then I go down, and right there's a relative minimum. That's 1, that's 2, that's 3. And that's the statement that there are 3 relative minimum values. That is correct. And the absolute max value has the y value of 3. Is the absolute max at 3? Well, yeah, the y's at 3, the y's at 3, but it's not an absolute. Those are relative max values. This thing goes up forever. The absolute max value is technically positive infinity, not positive 3, because it goes up forever. So this is incorrect. Ladies and gentlemen, again, this is the midterm. There are no retakes. So please do your best. No redemption questions. It's a one-shot deal. Take it serious, guys. I hope this video helps. Good luck.